Hey guys, welcome back, and today we are going to talk about some internal forces that are shaping our Earth and some of the stuff that's going on beneath the surface. And specifically, we're going to talk about plate tectonics when it comes to our globe. So make sure you've got something to write with, take down some notes as we go through and talk about these forces here. This is chapter number 2, section 3. So plate tectonics, essentially what happens here is that we have our Earth, and underneath what we see as the ground layer are a number of plates. They're called tectonic plates. Very similar as you see on this basketball, where there are lines all over it, and if we were to take this basketball apart, we could peel apart each of those layers and they make up a specific part of the surface. So those tectonic plates are massive pieces of our lithosphere that shift as they sit on top of the heated rock, and they can move all around our globe. There are 4 ways that these tectonic plates move. You can see those showing up there on the screen. The first one is through spreading. As they move apart, they can create a divergent boundary.
At divergent margins, lithospheric plates move in opposite directions. The plates, which include crust and part of the upper mantle, ride over the asthenosphere. As hot mantle rock rises to shallow depths, it begins to melt due to lowered pressure. This forms magma. Dense plutonic rock is created as the magma is injected into the crust. Small magma chambers form low in the crust. Less than 1/4 of the magma ever reaches the surface to erupt as pillow lavas. As it moves away from the ridge, the cooling rock sits progressively lower than the hotter, more buoyant rock at the ridge. Like 2 giant conveyor belts, the plates transport newly formed oceanic crust away from the ridge crest at 3 to 10 centimeters per year.
As they also sometimes will subduct. That means that one kind of goes on top of another. And as this happens, it makes a convergent boundary.
Area where the floor of the Pacific Ocean dives deep below the Australian plate in what is called a subduction zone. The seafloor is buckled and pulled down into deep trenches, and the friction triggers powerful earthquakes as the Pacific plate is slowly consumed. Even here, magma flows from underwater volcanoes as rocks are melted and recycled. White Island is one of a chain of volcanoes that includes the notorious Tarawera.
That was quite a bumpy flight. But it's worth it because we're right on the Pacific Rim there, aren't we?
We are. This is the Pacific Ring of Fire at its best. There aren't many places where you can see it so graphically.
So we're literally walking to the edge of the Australian plate, and right in front of us is the Pacific plate.
Well, not quite going that far. I mean, we really are entirely on the Australian plate here. But this is where we feel the effects of the downgoing Pacific plate.
The third type of movement is a collision, where 2 of the tectonic plates get together and they collide into one another just like this. And again, that is also a convergent boundary, bringing 2 together. So both subduction and collision, they make that convergent boundary. Then the fourth way is through sliding. These are where the 2 plates are going to get together, but they're just going to kind of slide by one another and not necessarily run into each other. They might skid along the edge with one another. This is going to create a transform boundary. And depending upon the type of movement that's going on here, sometimes we may see a fault form. That's where there's going to be a fracture in the Earth's crust as the pressure builds. One of the effects of our tectonic plate movement are earthquakes. These earthquakes are caused by grinding and slipping plates. They are measured by a seismograph, and they are rated on a device called a Richter scale. In 1986, the largest ever recorded earthquake was the Kermadec Island quake, registered in 8.9. And that is very intense. Normally, they're going to be much less than that. A lot of earthquakes that happen, we don't even feel and barely register on the Richter scale. In fact, right here where we're at, we're probably not going to feel any sort of earthquake. We are not on a fault line, and the tectonic plate that we sit on generally is not going to show evidence of a noticeable earthquake. The earthquakes begin in an epicenter. That is the very central location. So if it's going to happen right here, that is the epicenter, and that is going to have an initial shock where it begins shaking and moving, and then it is going to spread out from that epicenter. And further away from the epicenter you get, the less of the effect of the earthquake you will feel, and the lower of the rating on the Richter scale you will notice. We can have aftershocks that happen after the initial earthquake happens. Now, if we have an earthquake that happens underwater, specifically out in the ocean, then there's a possibility we could have a tsunami. And a tsunami is a massive wave that is caused by some sort of disturbance under the ocean regarding the tectonic plates. The largest one of these tsunamis that we have ever recorded was in 1971, where there was a tsunami just off the coast of Japan that measured 238 feet. That is not a wave that I want to ride.
What is a tsunami? Tsunami is a Japanese word meaning harbor, sea, and wave, nami. Animals can sense a tsunami approaching because of their superior sense of hearing. People who have survived tsunamis say that it sounds like standing near a moving freight train. There are tsunami warning systems attached to buoys in the ocean that transmit data about the ocean and serve as a warning system. If the water along a shoreline begins to recede dramatically, it most likely means that a tsunami will follow in a few seconds or minutes. A tsunami is not just one wave, but a series of waves or a wave train. Did you know? When tsunamis are near the coast, they slow down but increase in height. Tsunamis used to be referred to as tidal waves but aren't anymore because they have nothing to do with the tides. Some tsunamis may not appear on shore as a huge wave but as a quickly surging tide.
I tried as hard as I could, but I could not find an active volcano to film in front of. So unfortunately, you're just going to have to use the picture provided, and you're going to have to use your imagination of what a volcano may look like. So as we talk about volcanoes, the volcanoes typically show up along the boundaries of our tectonic plates. As some of that molten lava begins moving toward the surface and seeps out in between the tectonic plates, it's going to create a volcano. The way it works is we have magma pushing up through the Earth's surface, and the lava is the result of the cooling magma as it reaches up the surface. So it's going to continue pushing upward. Some of you may have made a volcano back in elementary school, one of those with baking soda, and I don't even know what the rest of the ingredients are, but you may have made a volcano in the past. Skip that. I tried as hard as I could, but I could not find an active volcano to sit in front of for you to be able to see in the background here. So you're just going to have to deal with the picture and pretend that we know exactly what an active volcano is going to look like. But most of our volcanoes are going to appear along the boundaries of our tectonic plates. And the way that they're formed is that we have magma down under the Earth's surface, pushing up through some of these tectonic plate boundaries. So if we had one here, we might have some of that magma pushing up, and then lava is going to result as the magma cools near the surface. And as that cools and starts to pile up, we're going to see it float to the surface or kind of build up at the surface, creating that typical volcanic shape that we are used to. And so one of the more significant areas for finding volcanoes is the Ring of Fire. Out in the Pacific Ocean, this is the majority of Earth's volcanoes are found here near the Ring of Fire out there in the Pacific Ocean. A few things that we can notice as we see volcanic activity. Hot springs may show up. That is a result of the water circulating near the magma chambers, and those hot springs are constantly warmed by that magma that is flowing through there. Geysers can also erupt. If you've ever been out to Yellowstone National Park, one of the most famous geysers in the world is Old Faithful, and it blasts off every so often. It's very predictable. There are other geysers in the world. There are even other geysers there in Yellowstone, but most people go to Old Faithful because that one happens so regularly. And the way the geysers work is that that water below the surface heats to a boiling point. And as it continues to boil, then once the pressure builds up so much, it is going to just burst out of the opening there, and it's going to go high up in the air. It's pretty impressive when you see it happen firsthand. If you've never seen it, go to YouTube, get online somewhere, Google or something, and get a view of Old Faithful happening there. So I hope this section has been beneficial for you. Go back and replay and watch it again if there's anything that you need some more information about. And if you got any questions, come talk to me. We'll talk to you later.